Hello, everybody. This is yet another Scicloj meeting where we are studying the story of the data science and scientific computing in Clojure. And today we will have as our speaker Vlad Protsenko, who will speak about Reveal. Reveal, the new user interface, which is a wonderful variation of a REPL that we'll learn about. Vlad, would you like to present yourself?
Hi, I'm Vlad, and I made Reveal. So thanks for coming, and I would be thrilled to talk about it because I've been thinking about this for like a couple of years. So it's a long project of mine. I hope you will enjoy this presentation. Shall I start? I guess, or did you want to add anything else?
No, it would be great to start.
Okay. Okay. So, Reveal. A little bit about me. I'm Vlad. I'm a citizen of Russia, but currently a resident of Sweden, and I like programming. And my path in programming started in ActionScript, where I was doing Flash games. It was a really fun and like enabling environment because I could just write code and see something on the screen. But the language itself didn't feel very powerful. So when I discovered Java, I was blown away by its powers, which might sound a little bit silly now in retrospect, but compared to ActionScript, like being able to use generics to express myself felt very liberating. And then I found Scala, which was even more powerful in terms of what I can express with types. But I guess during that time, I started feeling that I'm more spending time on like playing with the type checker and trying to express my problem in a way that will be fully confirmed by compiler, which is a very big task. So then I discovered Clojure. I was again blown away by what can I do with it, and I feel that like we as developers want immediate feedback, and the kind of feedback that is provided by static types is really not the same, like not the type of feedback I want, because it's like types are completely, well, they are sort of related to runtime, but they're different language. And what I mean is like a whole different world. So there is like a compilation and compiler, and then there is runtime. And I think truth is in the runtime. So being able to play with the runtime instead of with some other program, which is a compiler, is a much better way to develop. And that's why I love REPL, because I can write some code and immediately see the results of it. Another, I think, amazing characteristic of the REPL is that I can combine various tools in a way that are just can't be done with the UI programs. For example, I can like there are two types of profiling the performance. One is like measuring the execution time, and the other is seeing like where the execution is spent. And using REPL, I can combine tools that do both and get get a more meaningful insights. For example, here you can see that I'm benchmarking merge and into when I'm for merging small maps, and you can see that for small maps, merge is faster than into, which is might be a bit surprising because usually into behaves more fast due to transducers. So this is like the place where profiler can give a more meaningful information for me. It's like saying where the time was spent. So I can see that in a into version, there is like a lot of time spent in converting a data structure to transient. So like I think this is awesome. And I don't really like UIs because they're usually very limited. For example, here you can see an Eclipse memory analyzer that allows you to analyze heap dumps. So I might have like a process that has a memory leak, and I take a heap dump and I look at it. But the problem is it doesn't allow me to deserialize the data. For example, I might have like a very big chunk of data, like a byte array that is there, but all I see is like individual bytes without knowing what are where do they come from, and they might come from like me using some binary serializer in the code. So like I could produce this this byte array myself, but using the UI I can't read it back because I'm limited by the UI that is provided to me. And I think this is where REPLs are much better than the UIs because the whole language is at my disposal. But there are some problems with the REPL. One of the big problems, I think, is inspecting big data or, well, big data structures. And pretty printing helps only to a certain point. If you want to inspect like a small piece of data you found in this big data structure, you have to manually track where it came from and like perform a bunch of get-ins to see what's in there. Another problem is that REPL is just the stream of characters, so I am not. It's not expressive enough to tell me like what's going on in some cases. Here, for example, you see that there are two functions, foo and bar, that return ratio given an instance of a ratio, but those are different ratios. Can you guess like what's the difference? We'll get back to that. Another problem, or I guess there are other solutions in this area, and one of those solutions is REPL, which is a visual REPL by Cognitect, which uses a Datafy and nav protocols as a like the main abstraction for navigating and inspecting data. And I feel there are some drawbacks to using those protocols. One of them, like Datafy, is used for converting objects to data. So you might have like an object that isn't data in your VM, and it converts it to data. And this is very useful, for example, if you are doing like if you're using a network REPL where you speak over wire, so you can't really send objects, you can only send data. But most of the time development happens like in the process. So if there is no need for networking, you don't have to pay the price of losing access to your data. So Datafy converts objects to data, and sometimes that might be very confusing. For example, it converts atoms to a single element vectors, and like, you might be very surprised to see it. Like you have to know it beforehand that it does so before using it. Otherwise, you might be very confused about what you're actually dealing with. And another problem with datafy and nav, by the way, it's used for like navigating into data structures or loading related data. And I think loading related data is actually pretty nice concept, and it plays very well with datafy. But still, the problem with both datafy and nav is that they are protocols. So given a particular type, you can have only one implementation for that protocol. So for example, if you have identification for string that returns like reflection information, you can't really add anything to that. It's like if you're using Java 9 and you have now model information that you want to see, like you can't just add it there because it will override the existing implementation. So that's why I made a thing, and the thing is called Reveal, and it's many things. It's a REPL and a window and a library to build REPLs, and yeah, here you can see the differences between foo and bar, by the way. The one returns class and the other returns symbol. And in Reveal, you can instantly see that even though the text is the same, the values are different. So how Reveal tries to be a good REPL that is that enables you to explore and understand your program. Well, the main approach I took is that Reveal is only about P part of the REPL, so it only replace printing with visualizing. That means you are still using your own IDE that or text editor, and it doesn't try to enforce you to like something in that area. Another thing is that its output looks like text by default, and this is like it's. I think I didn't really thought about that before I was starting to think about Reveal, but the text is actually already a very visual medium, and for a visual medium, it's also very concise compared to like various visualization tools that use I don't know, circles and lines to connect things together. As you can see here, like the text on the left represents the same information that this graph on the right, which is, by the way, a Luna long. If you are curious, it's like a visual language that is done by some startup in Poland. And yeah, text is visual. It's very dense, and I think this is very important to be able to like see a lot of data at once, because it allows us to think about the whole thing at once. The other thing is text is universal, so you can select it and copy it and save it to a file or send it as a snippet to someone. So it's like shareable. Another thing about Reveal is that it is an in-process tool. So it isn't tied to any IDE, and that means that it's available in any IDE or text editor that is able to send like forms to socket REPL. And I think it's very great for ecosystem if Reveal will be adopted, because it will allow IDE authors to focus on great text editing and linting and like structural editing and various analysis of the code, while getting a very powerful environment for seeing the results and inspecting the results. Another benefit of being in process is easy access to references. For example, you can select a text and in Reveal, every bit of text that is shown on screen has a reference to an object that produced the text. And that means that you can then evaluate execute different actions on that code. For example, you can select a text that was produced from an atom, and then derive the atom that was used to produce the text. Unlike DataFi approach, Reveal treats your objects precious. So when you evaluate a instance like of a var, it will show it as a var, not as a vector with a function in it. And it doesn't touch the metadata as well, unlike DataFi that puts its information about the objects into metadata. So you are able to see like what is really in your process instead of what was added to your objects by the tool. So what's next? Even though there are Reveal doesn't change your data, annotations are useful. So it allows you to put annotations beside the data. And that means that you can annotate any objects, not only the ones that implement IMeta. For example, here you can see I made a graph of associations and made a custom printer for that by default shows all the nodes in the graph, but it also annotates the individual keywords. Like it puts them in context that those keywords exists in a graph, and that allows to inspect like the parts of the graph, like connections, using those annotations. So here you can see that it can get successors of a keyword in that graph. And inspections are an open set. So given some objects, there are usually like a bunch of different actions that are built in that you can use, but you can also just type any expression you want and evaluate it. So you have like the whole Clojure available to inspect like any object, just like it is in the REPL, but you only need to select things. And this open set is extensible by users. For example, you might have like you might be developing a server for a like an online chess games and use Atom for for the current state of the games, and you might create a custom view that shows your games as chessboards. And it's very easy using Reveal to make those views and make them reactive. For example, here you can see I'm evaluating a command, like a form that modifies the server state. It moves the figure, and when it's evaluated, the view of your server is updated automatically. And another thing which I think is very important is that those views, like those figures, they were produced from data. So view is not a leaf. You don't have to give up your ability of inspecting data just by showing it differently. So here you can still select a night and get the value back and keep exploring. So this is what it is. Read Eval Visualize Loop. Now, I would like to mention some honorable features that are not that popular maybe yet, or not very well known. The one of those is a top. So I used to use print statements for debugging. I think prints are actually a very good debugging technique because it doesn't stop the execution, so you can more easily iterate on it. And when you print something, you usually print only the things you want. So it's like very like a focused way to debug your program. But the problem with prints is that a REPL that works with printing can only work with character streams, because this is what print is. It transforms objects to text. While top is a system which is similar to printing, but it preserves the objects as is. So you can, instead of printing, you can tap those objects and see them and still be able to interact with them. So after making Reveal, I stopped using print statements completely, and now I only use tops, and I think you should too. Other feature it has built in is a Java bin inspector. So I think it's very useful to be able to inspect objects in the VM, because we are dealing with objects in the VM, even when they are represent only data. So using Java bin action, you get a very inspector-like view available in IDEs, but you are getting it for free in every IDE where Reveal is available. So you can get a better understanding of your objects, and I think it's might be very useful. For example, you might have a look at the class Clojure keyword, and you can see that, oh, there is a bunch of stuff like package names, but there is also protection domain. I wonder what it is. Oh, there is some information about where it was loaded. Oh, there is a code source. So I can then inspect this code source and see that every class you have on the class path, like if it comes from some place like a jar, JVM has a reference to it. So you might be able to explore your data better. I don't know, someone might find it useful, but I mean, I didn't know that it exists. I learned it that every every class has a reference to a file it comes from. Only after I implemented this feature. So I think it's very interesting that, like, if you're dealing with, I don't know, some Java libraries, you might want to inspect stuff easily, and you can do it. Reveal can talk to remote processes. Here you can see that I have a terminal that runs Clojure script REPL. And then I configured my IDE to use reveal to evaluate forms on that remote process. So I am able to use my IDE to send forms to reveal, so it can send forms to browser, so that can evaluate code and give results back. So reveal isn't limited to be only a tool for inspecting like a JVM process. It's like a REPL, it can talk to remote processes, but you have to understand that there is some limitations coming with it. Is that the only thing Reveal can inspect then is not the data in the remote process, but it's not the objects in the remote processes, but the data that it received over the network. And like there is a difference, but it still might be useful for other features such as charts. So given a data in the right form, you can just view it as a chart, for example, here, just by having a map of something to numbers. I can show them as bar chart. And again, the view is not a leaf, so you can still select like any data point and get the value back. Another useful feature is tables that allows you to view data as tables, which is useful in cases where you have a very big data structures and you want to get an overview of those like layer by layer. It is extensible. You can extend the multi-method to provide your own custom formatters. Here, for example, you can see how it's done. So there is a Vlad Reveal Ext namespace that is used for extensions. And there is like a small language that there's like a very small set of functions that can be combined to produce outputs that are themselves like this syntax highlighted text that has references to those objects. And not only formatting, you can do custom actions. And the thing about them is that they are done only by, well, it's like as an open set, they're done by specifying like a predicate, and when the user asks reveal for a context menu, reveal evaluates all actions and shows only those that returned some function to execute. And that allows you to add about any inspection to any objects that you might think of. And generally, it is not a problem for performance, because for UI to feel responsive, there is like around, I don't know, 30 milliseconds window to run all those predicates, like all those actions. And this is well, unless you do some disk I/O, this is plenty of time. In addition to actions, you might create custom views, which are just a different variation of actions. So how does that work? The thing about actions is that like there is a difference between the main output panel and the bottom tab pane that contains evaluation results. And the difference is that the top panel can only show this textual output that is baked by REPL streaming formatting. But the output panels can show any node that is allowed by REPL's UI framework, which is JavaFX. And it uses Cljfx as a user API for specifying the views. So if any action returns an object which is a Cljfx description, which we will talk about in the second part, then it will show this returned value as a Cljfx node. So it will convert them to JavaFX nodes and to present them as a display graphs. And it is basically done by checking that return value is a map that has fx/type keyword. So this was my presentation of the things currently existing in REPL, but I am planning to do more. I think one of the bigger huge wins that REPL might gain is that access to web, because there are lots of very good data visualization libraries for browser, and currently REPL doesn't have access to them, which is not 100% true, because REPL can show REPL can embed web browsers. It's like web browser is a custom node that is available in the JavaFX. But I still would like to experiment with it to be able to retain this ability to get back the references to Java objects that were used to produce these visualizations, to not make this browser view a leaf, which currently, if used, it will be a leaf. Another plans I have, and this is something that Emacs users ask for, is ability to control REPL remotely, so they don't have to leave their operating system. I also plan to change how the output looks. I will probably, well, I mean, I haven't really thought that through completely, but current plan is to be able to show the results as a tree instead of a single tab pane. So the more context is preserved for where your output comes from, and I think it's also useful to be able to show multiple outputs at the same time, which isn't possible yet. And it's not like there is any particular reason. I just implemented it that way. And another thing I am planning to do is to make custom views being exportable. So I will probably start with exporting like views like charts and tables to PNGs, so you can like get your visualization and then share it with your colleague or loved ones. So yeah, that's about it for the first part. That is about reveal. Thank you for your attention. And do you have any questions?
Hi, is this better? Can you hear me?
Yes.
Well, thank you very much for this for the first part of the presentation. I apologize for the sound when we just started. I think it's fixed now. It's not so much a question as a word of appreciation for your work, because I was playing with Reveal, and I don't know if it's clear to everyone, but you don't lose anything by plugging in Reveal into your workflow. Whatever your workflow currently is, it just plugs in and doesn't interfere with your normal workflow. So it's all bonus. And what strikes me with Reveal is some kind of a if you just talked like half an hour about what it does, and I don't know how well people can absorb all these features. But if I was to summarize Reveal, I would bring in the context of liveness, and the concept of liveness is something that is extremely known in communities outside of the mainstream community, and also outside of the Lisp community. And I'm specifically referring to Smalltalk, which is a very tiny community today, but with a very big history and background. In the 70s, Smalltalk environments had a degree of liveness which was never matched since then. Like even today, with our fancy REPLs, we don't have the type of liveness that people had in Smalltalk environments. And you have to play with a Smalltalk environment to understand what I'm saying. You can download the stuff, there's still Smalltalk images and environments that you can use to just get a feel for it. You have this kind of Reveal reminds me the kind of liveness you have in Smalltalk environments. Everything is you have a grasp on the real objects, on the real thing underneath. While in our traditional REPLs, like you said before, it's a textual representation, which is not the real thing. And Reveal brings back the real thing in the print representation. And that is really awesome. And I think this is really the main thing that strikes me with Reveal, this kind of liveness that we thought was lost forever. People are not even aware. Most people are not aware that we have REPLs in the mainstream communities, and in the Lisp communities, we are not aware that we are missing out on the liveness of Smalltalk community. So there is a kind of irony here, and kind of sweet revenge as well. So that's what I wanted. That's what I wanted to say here. Thank you.
Yeah, my pleasure. I like the saying, Reveal, sweet revenge. There's a question, what's your take on tests? I don't really understand the question.
Yes, hello, it was me who asked the question.
Yeah.
I think Reveal is an awesome tool, but I felt a little bit surprised that when I quickly flickered through the code, I didn't find any tests. I mean, it's supposed to be a tool to help development, your development workflow, but it doesn't. Maybe there are. I couldn't find them. I mean, it was.
Yeah. So Reveal used to have tests when it was a private repo in my GitHub. Like earlier versions of that had tests, but actually it was quite nice. I really like them because I try to invest in spec and just like aspect my the main data types that Reveal uses underneath and verify that like a bunch of stuff works. And it was very slow, but very very good in finding hidden bugs. But I didn't really, I didn't move it to a public repo. And I think maybe it's because UI testing is hard. I don't know. Maybe it's just me being lazy and trying to like, I don't know.
Maybe you can explain why you want test. Are you planning to contribute to the project and this is something that is holding you off or something, Leandro?
Actually, I was curious more than any other thing because, I mean, I didn't expect a UI test, but I would have probably expected a backend test. I mean, just to make sure that given that it's a visual tool and it has to show information, just to make sure that it's showing the right information. I was curious about that. It's mostly that.
Yeah.
So,
sorry.
No, please don't apologize. I'm not asking for that at all. It's definitely not my intention. I was just curious that I couldn't find any tests or any kind of reassurance mechanism like specs or anything else. That's all.
Yeah, there are some specs in the code sprinkled here and there, and I use them mostly for myself for documentation, like to remember what is there. But yeah, I think it's like it's hard to test the UI, and I mean Reveal is mostly UI. It's like the only good way to validate is to see how it behaves. Yeah, I mean, I'm pretty sure there are parts of Reveal that can be tested like without visual confirmation, but yeah, I didn't write any test for those because I just tested those at the REPL and sort of rolled with it.
Okay, please, just don't consider my question as an. I'm not questioning your judgment. I was just curious about that.
Is there any other question in the audience?
You hear me?
Yes.
Yeah.
All right. I had double mute on. Hi. So let's pretend for the sake of argument that I don't really understand what tap is. It seemed interesting, but could you elaborate on that a little bit? If everybody's willing to listen to that, I can go do this on my own too, but that's new to me.
That's a good question.
Yeah, good question. So tap is sort of the same thing as print, but in the REPL, you see the value instead of text. That's the main difference.
It was introduced in Clojure 1.10, and it puts values, it returns true, which is a little weird. So when you use it, you get true back if it succeeds, which means it's a little weird to stick it into threading expressions. But it puts it on a channel, and then various things can listen to that channel. You can have watches for tap, and those watch functions get every value that is sent to tap and can do things with it. So, you know, if you you're doing some sort of debugging, you can add a tap watcher and capture the values, and then you can take the tap watcher away when you don't need it. So you can actually leave tap in production code, which is really nice, because it really puts very little overhead, and it just throws data away once it's got more than 1,000 values. And so that means that you can connect into some production process, add a watcher for tap, let it run for a bit, see what's happening, and then remove the watcher, and off you go. So it's a really nice debugging feature.
Are you using it in Angular, Sean?
I use tap for all my debugging, and in fact, the way that I use reveal is via tap. So I use Atom as my editor with Chlorine. Right. And I have all my evaluations set up to send data to tap. And the kind of nice thing about that is if I've got reveal on my class path, reveal will display those values. But anything else can also listen to those values. And there are other tools like Portal, which lets you view everything in a web page. It's kind of a little bit like reveal, but you have a browser window running. And that also works with tap. So I don't have to worry about what external systems I've got connected and running. I just tap my debugging out and look at it in whatever tool I've got attached.
Very nice.
Maybe I'm not understanding it fully, but is there any sort of use case or practicality for logging or monitoring using this?
You could use it for logging. But there is essentially one tap channel in the system, so everything that's tapped in your system will go through the same place. And if you are tapping values faster than they can be dealt with, it's a dropping buffer in core async. And so once there's more than 1,000, it's 1,024, I think, values, it just starts throwing them away. So it's not intended for like production level stuff. But it's intended for, being able to attach to something, examine it, and then take that thing away. So you can have reveal, you could have portal, you could have all these things running at the same time, and they would all get every value that was sent to tap.
So does it need to be, the watchers have to be async if it plays with core async or not?
There's actually no core async.
No, it's not really core async behind the scenes. But if your watchers are doing too much work, then yeah, you're going to get a backup and you're going to lose data, because it's actually using a Java queue or something under the hood. Vlad, I can't remember.
There's just some queue.
Yeah, it's just some sort of little tiny faux thing. Yeah, no, it just looks a bit like that, and that's kind of an easy way to explain it.
Right.
But yeah, it's not designed for production leverage. It's much more designed for tooling, and it's used in REPL as well. Alex has said that he's going to introduce a version that is tap through with an arrow that will be you'll be able to use in a threading expression. So that'll actually be a much easier way to use it for debugging.
Mm. Nice, nice. So we did talk about this break, and I don't know how you want to do it, Vlad. We can ask if there is more if there are more questions, or if you want to make a tea break, or whatever we want to do. It's up to us actually. So
yeah. So if anyone needs to stretch their legs, we might have a minute, but otherwise I'm ready to continue.
Are there any more questions in the audience on the first part that that Vlad has introduced?
Okay, none it seems. Then I'll go on.
Okay, great.
Yeah.
If you're up to it, sure.
Yeah, I probably should have started saying that, but now that the moment has gone. So the first part of this talk was about Reveal. The second part is about Cljfx, which is a UI library that Reveal is built on, and the one you use for creating custom views. And after that, if we will have time left, I might make a demo session where I use Reveal to extend some data science stuff, which will be a Neanderthal library for linear algebra, but I don't really know it. So, but I prototyped a bit with it. So if you want, you might stay, but like the main content will end after this talk about Cljfx that I'm going to give now. So Cljfx, what is it? It's a React-like wrapper of JavaFX. And what is a JavaFX? JavaFX is a Java framework or library for creating desktop applications using JVM. So like it exists in the JVM and it uses all the objects that are in the JVM. And before we go into details, I'd like to give a somewhat unbiased comparison to Electron, which is the elephant in the room when it comes to creating desktop applications. But this is mostly for you to be aware of, like if you decide to create a desktop application using Cljfx. They are, I guess, sort of similar. I would say that the language semantics are better in Clojure compared to like Clojure script if you are using it with Electron, because Clojure script has a different compilation model that requires, for example, macros to be defined in a different compilation stage, while in Clojure you can just use them alongside the other definitions. And yeah, this is because the Clojure has compiler in the runtime, but the Clojure script doesn't. And performance is great on both platforms. Yeah, because JavaScript VMs are not this slow anymore, and they have concurrency, and that works really good, but might not be very well known. At least I didn't know that JavaScript has pretty decent concurrency, like threads these days. But I think performance is still better on the JVM because it was designed and tuned for that. And the ecosystem maturity is higher in the Java. At least I don't really hear about Maven breaking with the same frequency as I hear about NPM breaking. Yeah, but you have to realize that industry support is very small for Cljfx because it's maintained by just one guy on the internet. And I think this is actually a very valid point and valid benefit of using Electron and browser is that it originates in documents and it has a lot of very good typesetting tools for that. And by typesetting, I mean like being able to select all the text on the page or being able to just search for any text on the page or increase or decrease all the font sizes. This is like, these are things we take for granted when using web pages, but those are non-existent in JavaFX. So if you want to do something like that, you will have to implement it yourself. So here in the top left corner, you can see a Cljfx description, and it's a map, and it has a special Cljfx type, which is a keyword that describes a JavaFX class. So it is first of all, it means that you still have to have some knowledge of JavaFX that is behind Cljfx, but like the translation of terms is pretty straightforward. So JavaFX has properties like text, and Cljfx just uses keywords like text for that. And for listeners, it uses like on exchanged convention. So the description you have at the top is roughly equivalent to, like, if you were to just use JavaFX, it would be roughly equivalent to code at the bottom that just imperatively configures the text field. But there is a benefit to data, is that we can work with it as data, and that means that when the data changes, we can create a diff, like, to see what exactly changed and do a minimal updates. And this is like one of the killer features of React, and this is sort of the thing that Cljfx is. I think it might be worth mentioning that there is a different syntax popular, at least in the Clojure script, which is reagent, which uses keyword vectors, where first element is like a type tag, and the second might be a prop map with properties, and then you will have children as remaining elements. And I think maps are better because they are more easily modifiable from text. I mean from code, so you can, like, updating some prop programmatically is just as single as source, while in reagent you have to, like, pick a second element, check if it's a map. If it's not a map, you just insert new map and do a bunch of stuff. And another reason for going with maps is that Hiccup by default allows like every object to have children, and this goes from the HTML approach, where almost every tag can have children, and you can put children anywhere. But this is not true in JavaFX. So, for example, text field, it doesn't really have children. There is just nowhere to put them. So why make it expressible? And in addition to keyword fx types, you can use functions, and Cljfx will call them for you and expand that to a resulting component tree. And there is quite a lot of built-in components, which I summarized on this slide. As you can see, there are a bunch of 2D shapes, and I should also mention the canvas, which is the last 2D shape, which is actually a sort of like a canvas that you can use to draw other shapes, which is more performant when just using various shapes as nodes, as JavaFX nodes. Now, JavaFX is able to display 3D, and I was surprised to learn it can do that, but it can. Then there goes layout nodes that are about positioning and aligning and showing, like, adding spaces and paddings between other nodes. So you can see there is like horizontal, vertical grids, and the way to lay out your nodes in grid pane. And then there are text such as label and hyperlink. And I should mention that after text, there are like these 4 categories of input, visualized lists, and charts and multimedia. And those are like the areas of JavaFX where things start to get a bit messy sometimes. Those are, I guess, that's just because they are implemented as a mutable soup of mutation. There are just bugs here and there that come up from time to time. It's not horrible, but beware. So yeah, there are various inputs such as texts and buttons and select boxes. And there are virtualized lists that allow you to show like a huge collections of elements without creating like nodes for all of them. But just by showing like a subset of that and keeping internal state to minimize the memory use. Then there are charts. Some of them you already saw in the reveal presentation. And then there is multimedia, which can show videos and web pages, and even crappy what you see is what you get text editor, which I have no idea why they added there, but it is there. Now, yeah, those are things that are not really related to reveal, but more about Cljfx. But I think they're worth mentioning. One of them is CSS. JavaFX uses CSS for styling its nodes. But the problem with CSS is that it's a different language that is very problematic if you want to reuse parts like of the styling information. And the problem is that not everything can be styled using Cljfx. Not everything can be styled using CSS. So it inevitably leads to duplicating of styling information in code and in CSS. And to solve this problem, I made a CSS library that produces CSS files consumable by JavaFX just using data structures. Here you can see that there is a bunch of defs, and those color definitions are used to create CSS, but they are also used to like just as is those variables in the various parts that can't be styled, like a drop shadow color in this example. Yeah, and in another thing you don't have to deal with in Reveal is Windows, because Reveal is already a operating system window, and basically all you have to do in Reveal, if you're creating views, is custom nodes in the display graph. But if you were to use Cljfx to create desktop applications, you will have to deal with Windows. And here you can see that it's done in the exact the same way as it is with display nodes. So it's just different FX type, which is a stage, which JavaFX decided to use for Windows. And then there is a packaging, which is actually a fairly recent addition to a GVM toolset. So I think it was like this March, maybe a bit earlier. I don't quite remember, but Java 14 was released quite recently, and it added a tool called gpackage, which allows you to get an uberjar and the main class and compile it with the GTK to a standalone executable that can be installed on the operating system. And I think it's very useful because if you are like creating a website, basically all you need to do is like create an HTML, and it will be available in every browser, in every operating system. But if you're creating a desktop application, every operating system, such as Mac or Windows or Linux, they have very different ways to package the applications. And this gpackage tool is what makes it all affordable. As in React, Cljfx uses special keys to make re-rendering more efficient. For example, it can make nodes be reordered instead of recreated when the order of children changes. It has extension life cycles, which basically means that a fixed type underneath is baked by protocols that define how various probes on this description are handled. And you can override that and extend it to your problem in case there is something missing. So I think it's a good tool. And now we are slowly getting back to review. REPL extensibility namespace has a bunch of built-in views that can be used for creating custom visualizations. One of them, the most basic one, is a value view, which uses the streaming formatting and allows you to view values as like leaf values. The other one are ref watchers. Actually, I think I didn't mention that in initial REPL presentation, but REPL can watch any ref and show it either as like a latest value at the ref or as a log of all the successors, which are two built-in actions available on any reference type. And those are made using this ref watch latest view and ref watch all view that you also can use to combine them to create your own views. Like here, for example, where I created like a horizontal pane where the first half of it shows the latest value and the second half shows like the log of all values in this reference. Tables that REPL uses are also available as a custom view, which is a table view, but the difference with the built-in action is that you have to provide columns by yourself. And basically the built-in action that allows you to view data as tables just has a little bit of heuristic how to find the columns, like what they should be. Then there is observable, which is sort of similar to ref watchers, but the difference is that observable view allows you to create your own view completely, while the ref watchers only shows them using this built-in streaming formatting. And this might be very useful. For example, if you're iterating on some function that does some complex data processing, and you want to see how it works on some input data while you are working on it. But for the sake of example, I will use here a map invert, which should be very straightforward to implement. And as you can see, so first I define a dummy map invert function, and then I create an observable that watches it. So now I have a view that always shows the result of calling that function with my input. And then I write some code and reevaluate it. And just as I evaluate the form that changes map invert variable, it immediately updates the view. I would say, as I was writing that was quite a very interesting experience. So yeah, now I can see the bug and fix it and see the results of the fix immediately. I mean, it's not a thing you always do, because REPL is already quite a fast feedback, but it happens from time to time when I have like some piece of data and some data transformation I have in mind, and I just I used to like redefine the function, then try it, then redefine the function, then try it. Here I can just iterate on the function and see the results immediately. Now there are charts. For example, I might have 2 brokers that I used to buy stocks, and I might want to compare them in a various way. For example, I can use pie chart to see like how the combined portfolios look like, what is my most and least popular stocks. And then I can use bar charts to compare them. And it's all pretty easy to do. I just create a data like in the correct shape. There are line charts, and basically to have a line chart, all you have to do is a sequence of numbers. And well, in this example, it is wrapped in set because line chart actually shows it can show multiple lines. So it's a multiple data series, and that means that it has to be in some kind of collection that identifies the data. It's like it can be in a map where keyword is sort of a label, or it can be in a set where the sequence itself is an identifier. If it sounds confusing, all of that is documented in the docstring, so you will be able to find it there. Yeah, and there are scatter charts. They show points scattered on a chart. It's not as useful as having like a proper geolocation, like a map view, but it is something that was built in. And finally, the most important thing is, well, not the most important thing, but the important thing to make the views explorable is pop-up view. So every custom view you create, it doesn't have like a pop-up with associated value by default. You provide it yourself, and that way you can create explorable views. Here, for example, you can see an atom with a number, and I created an observable view of that atom that shows it as a slider with a callback that updates an atom. So whenever I move the slider, the value in the atom changes. But in addition to that, I wrap it in the pop-up view where I reference this atom. So now I'm able to press space or click with the right mouse button on the slider, and I can then work with that atom as an atom, so I can get back to the data that was used to produce this view. This is nice. So in summary, I think if REPL is a window to a running program, then Reveal is a door that that is open. You're welcome to come in and look at the objects from whatever point of view you want. And there are tools to create those point of views that are using Cljfx. Thank you for your time. Any questions?
Thank you, Vlad. It's really impressive work. Yeah, who has questions for Vlad? Let's hear it out. Hi, Sami. Good to see you, by the way.
Hello. I have one question. And yes, earlier you mentioned that Cljfx doesn't have a big community.
Well, I meant the industry support is that there are like lots of companies that have stakes in browsers functioning properly, and Cljfx is only supported by me. So you just like a warning, there are no tests. If that's what you mean.
Okay, so were you referring to only you maintain it, or is it that it has a small number of users?
I don't know the number of users, but I do know that there are users because I receive questions from time to time. So like I'm aware that there are people using it, but I don't know. I just don't know the numbers. But it is used.
Actually, the comparison should have maybe been between Electron and JavaFX, right? Because JavaFX is maintained by or supported by a whole ecosystem. So Cljfx is a wrapper on or DSL over JavaFX, but it's not. I mean, it's when you compare Electron, you maybe can also bring in the positive points about JavaFX, right?
Yeah.
Yes, I was wondering about specifically about Cljfx, simply because there's always the possibility, and of course, let's hope that doesn't happen, but it can happen that as you are adding a new layer on top of JavaFX, there's also the chance that bugs could be added as well. And that's probably, I'm asking, what Vlad meant by enterprise support, right?
Yeah, there is no enterprise support. I have a yeah. I am employed at an organization that has nothing to do with Cljfx. So unfortunately, I can't provide paid support. Or
no. I was referring to the the development team size. I mean, from what you told, it's only you or mainly you. So,
Yes.
so that was what I was wondering about, not about JavaFX specifically, but about this wrapper.
Yes, it's mainly me. I mean, there were a couple of contributors with like a smaller improvements, but yeah, it's done by me. And I mean, I think it's sort of done. It's not like I'm fighting currently, like having some kind of a roadmap for Cljfx with like features to it and bugs to fix. There are no features to it and bugs to fix. And I'm using Cljfx daily with the like a wheel. So I'm not really having any problems with it.
Thank you for your answer.
Good question, by the way. It's a it's a catch.
This is very typical of open source projects, right? It happens all the time. This is a consequence of the way our industry is set up. Yeah, have to live with it.
No, I mean, my point was just to clarify. Just my point was simply to inquire. Okay, anyways.
Yeah, inquire.
Thank you. To inquire about the development team size, because I mean, I know that JavaFX is very mature. I know it's used by many projects. But if I want to, which I am very eager to, by the way, try Cljfx, I would also take into account that new layer I was referring to.
Yeah,
that's exactly what that's a very good point in my opinion. This is how when you choose your dependencies, you have to understand that every time you add a layer, you add risk, and you have to assess how much worth it is. And this assessment is being done by you, right? So you have to go through the source code, see or use your familiarity with the project and the people around it and stuff like that. Yeah, of course.
Vlad, can I ask something?
Yeah, sure.
Yeah. So what you were showing with Reveal and Cljfx is mind-blowing. And it really, it really is so different from the current usual habits of people exploring data. And many of us are used to some linear flow of something that looks like a notebook where we ask a question and get a visual result, and ask a question and get a visual result. And we have this notebook thing. And so you open so many possibilities which are different from the usual habit, but it does raise a question. Do we lose something when we become so much non-linear? One thing we may lose is the ability to have a linear story of what we were doing, but maybe not. Maybe you have some thoughts about how we could document the process. Do you see what I'm asking?
You mean like a history?
Yeah.
Yeah,
Thank you.
I'm not sure I'm seeing what you're asking, because Reveal as a REPL has the whole output as a text that you can select and copy and save. So this is sort of like there is a linear history of forms sent and results received. It is not a notebook, but that's because I didn't try to make one.
Mm-hmm.
My intention was to make a tool for like a general programming workflow that I have. And
Yeah, this is a clash of cultures, huh?
yeah, I was thinking about it. Is that I was surprised to receive like an interest from the data science community, because what I did, I mean, I don't know much about data science. I just made a tool for me that allows me to explore like the program I'm developing, and it sort of has a bunch of visualization tools in it, like tables and charts. But I mean, I'm not using those during my development all the time. I use them only very occasionally, and I guess this is because I feel that the like general programming, and this is, by the way, one of the idea I want to explore, but I don't have any like concrete feature plans for that, is that I think the general programming is not that visual. It's like there are relationships and abstractions, and like the relationships between those abstractions are like very intense. There is like a huge web of everything connected to everything that I have to have in mind when I'm programming. And I don't think there are good visualization tools for that yet. I don't know. Maybe I'll come up with something, but yeah, this is sort of the thing I'm thinking about from time to time. It's like, how can I visualize what I have in my head when I'm developing like a program that is not that visual? Yeah, but yeah, so Reveal doesn't try per se like to be a data science tool. It just happens to be data science tool.
Hi everyone.
Hi.
Great presentation. Thank you. I'm gonna go and play with this tomorrow when I wake up, not anymore today. But a short comment. I think, I mean, what Daniel said, the last Daniel said is very true, that you have, in data science, you have a lot of this linear exploration notebook way of working, but it is not the only one. I mean, there's also, when you do explorative data science, you use often sort of a REPL-like experience, and I see there's a lot of promise in what we saw now. But I was a bit interested in, because if I understood correctly, the visualization views, they come from the JavaFX library, right? Or are they something that you built on top of it?
Yeah, no, yeah. Charts and tables are built in. This is why I made them, because I could do that easily.
Yes, and how happy are you with them? How mature are they as tools?
Well, I want to add. I really want to add D3 support. If that answers your question.
Then my question is why? Why do you want to? I understand you answered my previous question, but what are you missing? What are the main aspects?
I guess it's like, as I mentioned earlier when I was like giving sort of a short overview of different like areas available in JavaFX, is that the more complex you go, the buggier it gets, and so like it's like, I'm not sure I agree that JavaFX is very mature. I mean, it's old, but I feel it has bugs, and it's maybe not configurable enough to my taste. For example, the chart views, they have like no, not the chart views, the scatter chart. I don't have an easy way to configure like the size of those circles. And then I was trying to visualize like what was it? It's like a stock market price history for companies invest in, like just to compare stocks. It's like when there's a lot of data, they're just like they are too big, these circles, and I would prefer them to be smaller. And so I feel they are. It's like they are not designed for data science or for like very like configurable use cases, very like sensitive use cases. But I think it is really useful. So that's why I am also wanting to have a support for using like JavaScript libraries for visualizations to have like some good stuff.
Yeah, the web view.
Yeah.
Great,
yeah.
thank you.
There is a question about Clojurists together. Yes, I was thinking about applying there, but I mean, I have a full-time employment, so it's not like I will have a lot of time off. And it's a legal stuff, I guess, because I will need to pay to do like the paperwork to like to what's it like? I will issue an invoice. I think it works that way, and do taxes and stuff. And as I said earlier, I'm a resident of Sweden, and it's like a relatively unknown country for me because I don't live here long enough to be aware of all the intricacies of how it should be done here. So yeah, I was considering it, but maybe later. Any other questions?
I had more of a thought than a question, but do you, and this is kind of to everybody, but do you guys see a path to using Reveal and like the observable specifically? To me, made me think of how much easier my life would have been learning Clojure and some of the built-in functions and understanding something like transducers to watch how my data changed and what's actually happening and data flowing through pipelines like that. Do you think that something like this could be used to help onboard people?
You mean onboard into Clojure?
Yeah, onboard into Clojure. Yeah, I'm trying to get more adoption in my company and on my team for Clojure, and a lot of people say, well, it's just so different than what we're used to. But having some sort of, I don't know, tutorial, something that you can step through yourself and learn the sort of REPL workflow like this of run it, see it, watch it change. I just feel like it's good in multiple ways to teach people how to get into Clojure, right? Especially that the workflows that you can get into. But like I said, more comment than question, just seeing if anybody else is interested in that idea.
I think that's exactly what the consequence will be with a tool like Reveal, because your REPL suddenly becomes a Revel. the print becomes a visualization thing. So it's the gift of Reveal. It's that you can suddenly write your code in the REPL and visualize it differently, with more liveness than in your normal REPL. That's my take on it. But excuse me, the question was addressed to to Vlad. So go ahead, please.
Well, yeah, I'm a bit torn on this question because, yeah, I do agree that like in my daily use of Reveal, I feel that it helps me like to get stuff easier and faster to understand it better. But at the same time, it's like a thing you have to set up. Yeah, so it's like a separate REPL, so you have to know what REPL is and how to like combine them together, maybe. So you are. It's like it definitely has some. It requires effort to start using it. I mean, it's not much. It's like just a dependency, and basically you can run main as a normal REPL, but I guess when you're just starting, that might be too much. No, I don't know. Just a thought.
Yeah, I see what you mean. I'm curious to hear what Sean might be thinking, because Sean is a pillar of the community, and he's extremely active in helping people get on board. Do you have any?
Sorry, I was a little distracted there because my delivery of beer has just arrived.
Oh,
there's
great.
a service called Beer Drop that sends out craft beer every month. So
amazing!
My wife just went to the door and got that.
Excellent.
Yeah, I mean, I use Reveal all the time. I was using Rebel all the time before, because the main thing that I found very helpful about Rebel was that as I'm evaluating values, not only do I get the normal REPL where I see the representation, the printed representation, but Rebel automatically displays both metadata and a table view of the data, if it makes sense. And so, you know, if you're evaluating things that produce maps or vectors of maps, you get a much clearer view of it straight away. And I have it running side by side with my editor in full screen. I got a little frustrated with Rebel because it wasn't being evolved very quickly by Cognitect, but it was certainly very slick, and they were clearly using it all the time in their work. So when I first started looking at Reveal, it didn't kind of give me enough of the Rebel experience, and I chatted with Vlad online quite a bit, and he sent me a snippet of code that essentially stores the tapped values in an atom and always displays the last tapped value in a table using whatever table view it is. And that gave me almost the Rebel experience. And what I've done is extended it out into 2 panes. So now I have it automatically display the metadata and the table value. And so, you know, that's my sort of day-to-day work environment now. I have Atom taking up most of the screen, where I'm developing the way I work with Atom with Chlorine is that it doesn't have a REPL panel that you can type into. It just displays the results, and I have it minimized at the bottom. And then I have Reveal taking up about 1/3 of the screen, so I get the sort of traditional printed REPL output. And then I get the table view automatically below. And I certainly find that the visual representation of the data structures it saves me having to drill into a lot of the data, because that's what I was finding before. When I'm working in the REPL and I get a printout of some massive data structure, I've got to go, oh, like I need to take the first one of those. What does that look like? Oh, now I need to just select a few columns out of it. And having that automatically displayed in a grid is a huge time saver for me. And the ability, you know, as Vlad's just shown, that you can attach observables to anything, so it can like automatically run a function every time you change a function. That was super cool. I'd never seen that before. And of course, you know, it makes perfect sense now knowing what I know about Reveal and Cljfx, but I think there's a lot more that you could do in terms of building a customized visualization REPL that suits your own workflow. So if you're doing something that is heavily visual, where you want to produce graphs, you could set it up so that it automatically produced a graph from whatever value you're evaluating. So there's a lot of nice stuff I think you can do with the automation there.
Interesting.
Was that a reasonable answer to the question?
It's a fantastic answer. I think.
Cool, good.
Jake, do you have any follow-up questions on that?
Not really. I was just throwing it out as because I spend most of my time understanding things by printing it out. You know, that's part of the reason I was so excited to be here today. But I'm just curious if that would make people's onboarding process to Clojure easier. And I'm wondering if there's a way that we could set that up. Like I personally, I just set up Reveal for the first time 2 days ago, and it took me all of one copy and paste, and I was running, and it was great. I'm imagining there's plenty of people out there. Like if you're knowledgeable enough to look for Clojure and look for resources on Clojure, you can copy and paste something into a terminal, right? I think that's a reasonable assumption. And from there, if once we've got them doing that and opening a REPL and following along with, like I'd mentioned a tutorial, I find tutorials useful. I think you can see the REPL workflow, you can see how Clojure works, you can watch how, you know, like I said, standard built-in functions are modifying data and go, oh, this is Clojure, this is it. I don't have to go rewrite, like how many times I've rewritten for loops to do basic data modification that is just available to me. And I think that that's a good learning process for people. And that's as we were talking about this, it's all I've been thinking about. So I think it's a really cool tool, and I'm excited to see it.
Great, and I would be very curious to see how you manage to incorporate this tool in the process of onboarding in your company. If you're doing that, if this is part of your responsibility, I would love to hear more when you get a bit more experience with how does it work with your team or with the people who need onboarding. Really curious, because it's a big question how we do that, how we help people get on board.
Can I ask something? Oh, sorry.
I was going to say, on the onboarding side, I think if you've got a good curated setup for developers that is a sort of standardized way for the team to work, that helps a lot. I mean, we don't onboard new developers at our place very often. We have very low turnover, but we have scripts essentially to build your development environment, and a lot of the tooling that we kind of recommend to developers is built into our repo. So, I mean, we're all on the Clojure CLI and stuff. And so there's sort of a whole bunch of standard aliases in that where we say, okay, you know, this is how you start a REPL with your tests. And we could say, you know, this is how you start a REPL with Reveal. And then you just attach your editor to it and off you run, kind of thing. That said, you know, Clojure's developers as a whole are pretty heterogeneous, and the tooling they prefer is quite a broad spread of things. Yeah. So, you know, I'm working with a developer who prefers Emacs in inferior mode, and so, you know, he wants to start a REPL from Emacs, and that's his integration with it. You know, he could use Reveal, that would work. I like an actual editor and a socket REPL. Neither of us use NREPL, neither of us use Cider or any of that stuff. So we're both fans of very minimal tooling. I think the nice thing with something like Reveal is it's very composable with that kind of approach. And I do sort of wish more people would look at onboarding new developers by starting them with very, very simple tooling and showing composition of tooling, which is kind of the Clojure way, rather than, you know, oh, here's Line it slices, it dices, it builds jar files, it deploys things, it does all this stuff, it runs your tests. And the same kind of goes, you know, with some of these other packages. If you can get people to understand the individual pieces and how we compose stuff, I think that's very helpful in onboarding developers. A lot less magic. Yeah. So, sorry, Daniel, you were about to ask a question.
Oh, Daniel. But what you said was so inspiring and so important. What I just wanted to ask Vlad, I think you mentioned that you could share some session with us.
Oh, you mean leave demo time?
Oh, yeah. Just curious about that. Sorry.
Yeah, I can try to do that. Yeah, let's do it.
I'm going to drop off at this point, guys. So thanks very much.
Hey, thanks, Sean. Enjoy your beer, huh? And let us know.
Thanks.
Thanks. Enjoy, Sean.
Yes. So here you can see my setup. I use cursive, which takes 2/3 of my window, and then reveal that takes the remaining third. And like in cursive, there is also this REPL output pane, but I just don't use it at all with the reveal. So let's try. Yeah, I prepared a little bit of code for that, but the idea is to try and show how you can adapt various tools to reveal and to show its extensibility features. Here, for example, yeah, and the idea is that I can show you how to like adapt Neanderthal's matrices representation to make it like more explorable. There is a little bit of code prepared that is mostly about formatting, which is I would have troubles to to do it. But here you can see like that's how I work. So there is like a function, and I can just relate it, and I'm in the wrong namespace, and you can see it, that there are results in the reveal window. So if I want, I can expect it somehow. Yeah, but the thing about Neanderthal is that it here you can see like a matrix, and when you print it in your regular REPL, it looks like that. Yeah, so there is like some information, and then there is this chart or like a table view that shows the contents of that two-dimensional matrix. And it has some clever tricks to show the numbers, so they are fixed width. And like this scales to very big numbers. So when the numbers get too big, they're just like shown as exponents. And I extracted that logic in the fixed width number. Yeah, but as you can see, the problem with that is that those numbers are not precise. So you might want to be able to look at those numbers. So how can, like, if we are looking just at that representation, how that can be done in real? So this fixed width number is just a function that converts a number to a fixed width string, and it works like that. Now, in reveal, there's X namespace that I use for using its extensibility mechanism, and I can. There's a function called S that streams like the formatting for some value using a different representation. So like default representation for a number looks like this, and S allows us to override this representation here. Here's how it's done. So you format this number using some custom string formatter. Okay. And the thing is, those are like they are just a higher level functions that can be composed together. And this is done for performance reasons, but there is an escape hatch which allows us to stream those as is. So here you can see that I display my number as a fixed feet number, but since I used this as function that saves like the number that was used to stream it with this custom streaming, I can get back to that and I see like what is the actual number that is there. And maybe we might want to have a number like view of that. And this is done with color view. There is a README in Reveal that explains all this stuff. Yeah, so we now are able to show individual numbers as fixed width strings that allow to see them like in full if we need that. Now let's try to configure how we stream Neanderthal's matrices. So it's done with the devstream macro, which is sort of a sugar for dev method, but it has some additional stuff in there to annotate the value, to annotate the printed text with the value that was used to produce this text to enable this pop-up loop of exploring data. So we want to use horizontal formatting that shows it as it's like a beginning of this object. As you can see here, this matrix begins with the hash sign and then the class name of this matrix. This probably should be a simple name. Yes. And then open in square bracket. And we fill it as objects to make it like a yellow, so it's easily can be like easily seen as its own object. And then let's see how it is right now. So this doesn't really show any contents yet, but we will get back to that soon. Let's try some matrix and see how it looks so far. Okay, so yeah, this is what we have currently. We horizontally align first the string with the hash sign and the name of the matrix and the bracket, and then the closing bracket. Now we want to put the rows of this matrix between those. So in addition to horizontal that accepts streaming functions, which are those like higher level composition functions for creating streaming text syntax highlighted forms. There is also a horizontally, which is a variation that just streams a bunch of elements, and we will get like just not rows, columns, rows from this matrix. Let's just see how it looks like. So So here's a bunch of rows, and I actually want them to show vertically. Okay, yeah, but now the rows are displayed just as objects themselves, which is still not useful enough. So instead of that, we will configure them to show individual items. And these are, I guess, this is just done like that. Yeah, okay. So I just vertically stream every row, and from that row, which is a Neanderthal object, I just horizontally stream every item, which is a number. So we are almost there. As you can see, there are just numbers. But yeah, now we have to apply this streaming formatting to that. That makes them fixed width. So how does that look like? It's like 4 number in a row. Yeah, this snippet that we wrote earlier. Okay, so here you can see that now we show the matrices similarly to how Neanderthal renders them. But like the advantage we have here is that we can explore all those values quite easily. So we can just select them and request the context menu and view like the whole value that was in that cell in the matrix. So this is one of the things. And I guess I would say this is like a sort of a complicated stuff that deals with the going deep into objects and iterate through them to present them. Another example would be to creating a custom view using Cljfx's nodes. And yeah, I don't really know much about linear algebra, but I thought that those numbers from 1 to 0, from 0 to 1, they might represent like a heat map, for example. And we might want to look at this matrix not as a numbers, but as a heat map to see like where it's hot and where it's not. And that can be done sort of quite easily. Let's try it. So let's try defining a function heatmap view. And since it's a Cljfx description, it will receive a map with a matrix and return some Cljfx description. Let's start with something like label that just shows to do. Okay, let's view that. Let's have a look at how it can look like. Oh, I don't have it anywhere. Right. Okay, so here we have like just a value, but since it's a Cljfx description, we can just view it. So here's, at least we have something. Here's our to-do label. Let's try this observable view to iterate on this on our custom visualization of this matrix. Yeah, serve. Yeah, so we will watch Heatmap view, and so we receive a function, which is a new Heatmap view function, which we will use as a FX type, and the matrix will be, let's say it. Okay, so now we have this view set up. Let's try playing with this Heatmap view. Okay, does it work? Oh, it does work. So you can see that I just evaluated the label and immediately updated the view. So since it's a matrix, we will show it as a grid pane. Which has children. And so we want to iterate for rows and calls of this matrix. And return, let's start with just the label. Some text. Let's start with this fixed width number. An error. Oh yeah, because it has to be a range. Let's try it again. Okay, now we have this grid pane and everything is meshed together. That's because we didn't specify rows and columns. Okay, so here you can see is that now we are using Cljfx and JavaFX nodes to show this matrix. And yeah, they're currently looking quite similar.
Very cool.
Yeah. How about we add pop-ups? Set disk and value. So now we have pop-ups on every value. So we make those views explorable. As you can see, now I can just use keyboard to go through them. Yeah, so this is sort of easy to step if you know Cljfx. Now let's show those as like if you want to show them as a heat map, you want to show them like with the colors. So we will do it with just a different description. So we will use region, which is a basic like a sort of a div if we are making the parallels with the web. And I will set its width to something and its height to something, and highlight style. Okay. So here for now we have just a full red color, but we want to have this number which is currently which is what we have in the matrix to control the alpha. And yes, and we will need some string formatting. So I have this fmt function, and let's try it. I don't quite remember syntax, but it's like and then yeah, let's have a look. Yeah, okay, that looks right. So RGBA, first 3 are for colors, and the last is for alpha. And I don't remember it on the top of my head, so I just before this before this talk, I just used the JavaFX CSS reference guide and found how to do that. So this is one of the pages I frequently use, and you can find a reference to that in Cljfx CSS or on Cljfx README pages. So here you can see that RGBA, where RGBA is defined. Okay, so now instead of this number, let's copy paste it here. Boom. So now we have it running. And yeah, let's see. Like for example, this looks quite red, and this number is quite close to 1. And like this is completely dark, and it's pretty close to 0. And we still have all those exploration capabilities retained, so we can just have a look. Or maybe we might want to provide here a bit more information. So instead of just showing like the entry in this matrix, we can also show like what is the row and what is the column, and I don't know, why not the matrix itself? Yeah, let's have a look what we have now. Yeah, so quite easily we can add a bit more information here to see like where this number comes from. Okay, it's this row, this column. So now we have this heatmap function that just can show as a heatmap. And I mean, as you see, this is just a function that takes data and returns data. And we can then use it somewhere else. For example, let's define an action. That shows a heat map on any instance of matrix that we have in our reveal output pane. So when instance is matrix, let's just return this heat map view with this matrix. Yeah, we defined custom action. Then we selected an action, and then we can just here we can just view heat map of any matrix we have. Like let's search something else. Here, different. Oh, there is something old, but heat map is still available. So where you have it, custom streaming to show values and make them inspectable and explorable, custom views, custom actions. That's what you can do with Reveal.
Very cool, very, very cool.
Yeah, this is it. That's all I have today.
Wow, thank you. This is the kind of stuff that some people dream of having, but when you give it to them, they don't realize the value of it.
Yeah, it's like you have to know it exists, and then you have to have the courage to use it. Yeah, I don't know. Maybe I should make. Maybe I should, I don't know, make some video of how I do it and share it somewhere.
Always a good idea. This is the.
So I think the idea is you can use like you can have a custom namespace that you use in your dev time, that for the program you're working on, you can have reveal like definitions of various views and actions and formatters, and they are like they're not very big, like, and you can write them sort of easily.
Yeah,
that's the idea.
Daniel, do you think you can convert data scientists to this kind of workflow?
I think there is so much to think about now, because it simply opens possibilities that we were not used to thinking about.
Yeah.
And maybe, could I suggest maybe something? There is something that we sometimes do. After the talks, we organize small meetings where we meet to hack something without bothering the library author. I mean, the library author can join, but we do not need them. We, the non-experts, meet and try to do something. Maybe a session of this kind. And then we can get a feeling of how it is. And then maybe we can start thinking how much we could use it. So if anybody here is interested, then it would be great to think about this kind of hacking meeting, and we will also email about it afterwards and see if there is interest.
Yeah, I think these kind of meetings are very useful for everybody, because sometimes it happens that one is learning about specific tool or library. In this case, for instance, I'm learning about spec, and sometimes you have a silly error that takes you maybe a week to figure out, and you just ask someone who's experienced with the tool you are trying, and say, yeah, just try this little thing, and magically it works. So yes, it's very helpful, very useful.
Maybe I could say, maybe I could comment about what Daniel said. Could it be useful for data scientists? So actually, I think there are lots of tools that are used a lot by many kinds of people analyzing data. And these tools are mainly about a GUI, a graphical user interface, that allows to explore some data structures behind the scenes. And it is kind of a different culture, usually. There are those people who prefer a GUI and those who prefer to code. And these two cultures might not be meeting a lot, but now Vlad opens a door that allows to do both at the same time. And there are actually very specific applications that we know of, those GUIs that are actually useful for data exploration. But now we could just have them as a view of a REPL data structure. So we must try to use it in these very concrete cases. For example, you're doing machine learning and you have a decision tree. So you wish to explore this tree. And many people do that in a visual way. And there are tools that cost money that allows you to walk in the tree and look into the numbers. And now it could just be a view. So there is like giant potential here for things that could happen now.
You understand, Vlad? You should start asking for money.
Yeah, probably I should. Too late. I already released it as open source.
might not be too late. And I think that is an important question of how things could become like sustainable. And maybe some additional layers here could be a product that has a lot of value.
Yeah, definitely. Or look for third-party funding.
Mm-hmm.
Those are always options for developers.
Yeah.
And definitely this tool gets the best of both worlds. I mean, you can do the data-oriented exploration with just the numbers, but you also have the visual side of that, and that's really powerful, that you don't lose one thing because of having the other. That's awesome.
Yeah, thank you for your kind words. It's been my pleasure.
Thank you very much. Danielle, do you want to say anything before we wrap up? Or?
Thank you so much. It was so enlightening, and there is a lot to talk about now.
Yeah, I suppose. Is this recorded, Danielle? How does it work?
Yes, we will edit, just remove the prefix and suffix, and then it goes to YouTube, as always.
Great. So what do you need? How do you end generally the sessions? Do you offer people to hang around, or do we just say goodbye, or I don't know? It's a Scicloj meeting. We have to remind people. And Danielle is the.
I guess we can say goodbye. And yes, if anybody wishes to stay a little bit, then let us stay and chat.
I want to sleep.
Yeah, it must be late there in Sweden, right?
Yeah, 11:30.
Oh, okay. Okay, Vlad, thank you very much.
Yeah, thank you for your time.
Thank you. It's been awesome. Really awesome.
Yeah, cool. Bye-bye.
Bye,
Cheers
Vlad.
all. Good night. Bye-bye.